Hi students, I welcome you all for the today's session on the topic matrices, which is unit 2. In this chapter we are going to study the introduction to matrices, application of matrices, characteristic equation, definition and problems. Okay, now let us see what is a matrix. A matrix is a rectangular arrangement of numbers arranged in the form of rows and columns. You know, rows are nothing but horizontal entries, columns are nothing but vertical entries. Matrices consisting of only one column or one row are called vectors, whereas in high dimensional arrays of numbers are called as tensors. Matrices can also help to keep track of the coefficients in a system of linear equations. For a square matrix, the determinant and the inverse of a matrix behaves the solution of the corresponding system of linear equations. Eigenvalues and eigenvectors provide an insight into the geometry of the associated linear transformation. Now let us move on to the application of matrices. Primary application is matrices is widely used in all fields, engineering, arts, science, etc. Physics makes use of it in various domains, for example in the geometrical optics and matrix mechanics. Matrices encoding the distance of knot points in the graph, such as cities connected by rows, are used in graph theory, computer graphics and other areas to encode the projection of 3D space onto a 2D screen. The musical instruments of 20th century utilizes the square mathematical matrix to determine the pattern of music intervals. Now we'll move on to the next topic of matrix called as characteristic equation. First we'll see what is the definition of characteristic equation. For a linear transformation, the characteristic equation, otherwise called as latent equation, is defined as determinant of a minus lambda I equals to 0. This symbol, you know, it is determinant. So determinant of a minus lambda I equals to 0, where a is called the given matrix, form the linear equation. Lambda is a constant called as eigenconstant, and it is also called as characteristic constant. I, you know, it is a unit matrix or identity matrix with respect to the order of a matrix. Now let us solve the problems on characteristic equation. First problem, how to find the characteristic equation for a 2 by 2 matrix. The matrix given here is 2, 1, minus 1, 2. Now let us see what is the formula for characteristic equation. We all know it is a 2 by 2 matrix, so it will be ending up with the quadratic equation. So lambda square minus s1 lambda plus s2 equal to 0. What is s1? The coefficient s1 is called the sum of the main or leading diagonal element. So what is the leading diagonal element here? The leading diagonal elements are 2 and 2. So 2 plus 2 equals to 4. S2. What is the coefficient of S2? It is defined as determinant of A. You all might have done in your higher secondary level how to calculate the determinant. So the determinant is calculated as 2, 1, minus 1, 2. On cross multiplying, we will be having 2 into 2, 4. Then minus of minus 1 into 1, which becomes plus 1. So 4 plus 1 equals to 5. Therefore, the required characteristic equation is lambda square minus, in the place of S1 you put the value 4 and in the place of S2 you put the value 5. So it becomes lambda square minus 4 lambda plus 5 equals to 0. So this is how to form the characteristic equation for a given 2 by 2 matrix. Okay, let us move on to another problem of solving the characteristic equation. Now you all familiar what is the definition of characteristic equation for a 2 by 2? it is nothing but lambda square minus S1 lambda plus S2 equal to 0. So the given matrix over here is 1, 2, 0, 2. So how to calculate S1? It is nothing but the sum of the leading diagonal element, that is 1 plus 2 equal to 3. Then S2, how to find? It is nothing but the determinant of the given matrix. So it is 1, 2, 0, 2. So on expanding the determinant, we will be having 2 minus 0, which is equal to 2. Therefore, the required characteristic equation is given as lambda square minus 3 lambda plus 2 equals to 0. Have you understood for a 2 by 2 matrix? Now, let us move on to the next subtopic, how to find the characteristic equation for a 3 by 3 matrices. So, let us take a problem on 3 by 3, 1, 1, 1, 1, 2, 2, 1, 2, 3. So, given matrix is a 3 by 3 matrix. What is the formula for characteristic equation? It's a 3 by 3. So, the equation will be cubic in nature. Therefore, it is lambda cube minus S1 lambda square plus S2 lambda minus S3 equals to 0. Here, what is the coefficient S1? It is the sum of the leading diagonal element, which is nothing but, what are the leading diagonal elements over here? 1, 2 and 3. Therefore, 1 plus 2 plus 3 will become 6. Next, S2. What is S2? It is the sum of the minors of the main or leading diagonals. So, here what are the leading diagonal elements here? 1, 2 and 3. Is it not? So, what is the minor of the first element 1, which is nothing but minor of 1 is 2, 2, 2, 3. Am I right? Here 2, 2, 2, 3. Next, what is the minor of the second leading diagonal element? It is, you leave this row, leave this column. So, what is the minor of this? 1, 1, 1, 3. What is the minor of the element 3, which is nothing but omitting the row of 3 and column of 3, you will be having 1, 1, 1, 2. That's what written over here. So, now expand the determinant. We will be having expanding the determinant, will be having 6 minus 4 for the first one plus 3 minus 1 for the second one, and third one it will become 2 minus 1. So simplifying the equation leads to 2 plus 2 plus 1 will become 5. Now S3, as usual, we know it is nothing but the last coefficient is nothing but the determinant of the matrix. So what is the determinant of the matrix? 1, 1, 1, 1, 2, 2, 1, 2, 3, which is nothing but 1 into, it's a 3 by 3 matrix, is it not? So 1 into, you calculate the determinant for this. So 2, 2, 2, 3. What is the expansion? 2 into 3, 6, 6 minus 4. Next, second one, minus 1 into this element for row and column will be vanished. So it becomes 3 minus 2. Third one, expanding for 1, we have 1 into 2 minus 2. So simplifying the equation results in 2 minus 1 equals to 1. Therefore, the required characteristic equation is lambda cube minus 6 lambda square. 6 is nothing but your S1 plus 5 lambda S2 coefficient minus S3. S3 is 1 equals to 0. So, lambda cube minus 6 lambda square plus 5 lambda minus 1 equal to 0 is the required characteristic equation for the given 3 by 3 matrix. I hope all of you have understood about the concept of characteristic equation for a 2 by 2 and 3 by 3 matrices. Let us all meet in the next session with the topic Cayley-Hamilton theorem. Thank you, students.